So they recommend that when you degas your samples, the temperature that you set your samples to should be 1 to 5 degrees lower than the temperature you run your ITC reaction. So the standard reaction for the ITC set is 25 degrees. So then for me, I find that 24 has generally worked very well. So the reason why we set it to several degrees lower than the experimental temperature is because like when you put it in the chamber and the injector starts stirring, it's going to increase the temperature a little bit. It actually takes longer to cool down than it does to heat up the solution within the cells.
Mm-hmm.
Yeah. So the way that we degas, so first I have to remove the lids. And then we do is you just put it into these slots. And I always like to check whether it's stirring. Sometimes you need to adjust it a little bit.
Okay.
Because like depending on the viscosity of your solution, the stir bar might have a hard time spinning.
Oh, okay.
And you want it to stir evenly so that again it helps get rid of the bubbles that might come up during the process. So I'm gonna close the chamber and make sure that fits. And then you want to tighten this clamp. So you just spin it clockwise down. Okay, so you're not going to feel any suction just yet, but you just want to make sure it fits. So the way to turn it on, so there is the on button, which just like leaves it running until you like switch it off. But then this also comes in with a preset timer, so unfortunately we can't change the timer setting. But the timer is set to 5 minutes, which is the average amount of time you would need to degas sample in this type of this volume of sample. Right. So the way that you turn it, degas it with the timer, is you very quickly switch left and then to the center. Yeah. And then in case like something goes wrong or you notice that maybe you left the cap on, something like that, you can switch it off by turning very quickly to the right and then the center. So it's gonna look something like. Okay.
So let's just quick turn on and turn off.
Okay, why is it not going? Here we go. So this will go for 5 minutes. Yeah. Then you could check if it's suctioning, if it's like stuff like that.
And then after 5 minutes, we have to.
Yeah, that's when you load everything in.
Okay.
So I think in that time I could show you the setup. So it's a bit of a older software. So if a certain setting is wrong, it's not going to tell you exactly what. So I usually keep the PDF open here. So I believe if you go to 3.2, yeah. So from section 3.2 to about 3.7, it'll tell you everything that you need for standard run. So this is just an overview of the thermal back, which is the machine here. And then cell loading, everything from loading the sample cell, the syringe, you can find here as well. I really recommend looking over this part very carefully because this is like the hardest part, I feel. And then like after loading everything, it just essentially runs itself. And you only need to check back once in a while in case there's an error or see how your baseline is doing. Yeah. So in terms of the origin software, there's two. There's one to run the program, and then there's the other component to it that we use to analyze the data and create a nice curve like this, which is how we calculate our KD values and the delta H, everything. So ideally, it'll look something nice like this, with a relatively flat baseline. This is what a good curve looks like. But anyways. So in terms of the settings, this is total number of, so this is very straightforward. Again, we typically don't change from 25. So reference power is actually the difference between, sorry, it's the difference between the sample cell and the reference cell. So if you look inside, there's also like a diagram on here. Yeah, so on the left, you see the reference cell. So that has a white clock on top of it. We normally don't touch this. Like this contains water. So if you load it in with water, it's good for like a couple weeks up to a month, depending on how much you've been using the ITC machine. So I actually have here like a system for like last reference cell change and then last cleaning. So I clean more often than I change the reference cell because again it's like a closed system, I think. So yeah, you also see a view over here. So essentially when we have the reference power, so the unit is like microcal per sec, it's usually set to 10. That has generally worked very well for us. I don't exactly know why 10 is better than 15 or 20, but you know, these are the settings that Johnny ran with. So essentially when you like measure the microcal per sec, it's measuring the difference between the temperature or the heat in the sample versus the reference, which is the water, right? And the reference is always going to stay constant. So there's also initial delay. So that is the amount of time that you wait before you start injecting. So standard for us is that we wait 1 hour to see how steady the baseline is before injecting. So if anything looks particularly off, or like if there's a shift in the baseline, it's likely that it won't fall during your injections. Right? It'll likely happen during this baseline adjustment. Yeah, that's done. We can wait a little bit. Syringe concentration in millimole, we're gonna change to 100. So concentration 0.1. Stirring speed we keep constant at 307. These we normally don't change, but this is very useful for if we...
Concentration 100 millimolar?
Yes.
Nice.
So the syringe will have the ligand, and cell, which we'll load into later, will have our protein. Yeah. Or I don't know, what concentration did you choose for your protein again?
Now around 30 micromolar.
Okay. So that would be 3. Okay. So this is stirring speed. There is, again, the spatula that determines how fast it'll stir. And then these feedback, equilibration options, etc. All of these are for if we have an issue with the machine, then it will provide like the necessary data for IT to look at, and we can send a file to them. So it'll save under this name as a .itc file, and then that is what we could send to them for them to troubleshoot if anything goes wrong. And then injection parameters. So the average injection rate will be 0.5 microliter per second. So our typical volume is 10, and then duration of the injection is 20 seconds. Spacing, so that's the time in between injections. We use 3 minutes as standard. The filter period is about 2. I'm not entirely sure what that is, but that generally has not changed in between. Yeah. What else? Yeah, there's also an edit mode. It likes to automatically set to unique, so if you decide to change something, you want to make sure you hit apply the rest on the same, so it doesn't give you any surprises in your injections. And then these control the pipette, which again we'll load our ligand into. So I'll show you the process of like how to load afterwards. Another thing I like to do, which is a small trick, is that if I know what temperature I want to set my experiment to, I set it to it beforehand, so I don't have to wait for things to heat or cool as much. And then the others we don't worry about so much. We just keep the same. It's actually better that way, that we don't touch those too. Yeah. So now that we're done with this, twist this counterclockwise. Yeah, the other option to open it is to just remove this thing, but I'm afraid of this wearing down, so even just a simple like tilt in this direction, it works. Protein. So for me, cell loading is the more stressful part, which is why I do this last. So syringe loading is very easy. So what we're going to do is we're going to take our ligand. And there's attachment here. So it'll explain to you also in the manual, but I'm just going to show you how it looks. So we have several different syringes here. We're not going to go to all of them today, because some of them are for cleaning. But this is the syringe of the hose that you want to use for loading your ligand. So what you're going to do is you're going to find the syringe port. And that's this thing over here. What you're going to want to do is to open the fill port. So you wait for the noise, but also you see the plunger tip. It should be visible when it's completely open. Yes. So you can see this plunger tip is white.
Mm-hmm.
So once it's finished doing that, you're going to want to attach this hose here. Okay, I think I need to get closer because
Okay,
Yeah.
go ahead.
you just want to make sure it's secure.
Mm-hmm. Is it very fragile?
Yes. It also, like, we really don't want to damage or like bend the syringe tip,
Mm-hmm.
like the plunger tip, because then when it stirs, it can actually affect the delta H.
Okay.
In the cell. Yeah. So what you're gonna do is you're gonna draw up liquid until you don't see any more air bubble, or I guess until you don't see any more air. Yeah. So this is liquid from the previous run. Yeah. And once you're sure you don't see any more air, what you're gonna do is you're gonna hit close. So you're gonna wait until the tip stops moving. And sometimes I see a little air bubble, and that's why you make sure that it's closed completely. Let me just discard it here. So this we don't have to worry about so much because the liquid in here doesn't like go back into the syringe.
Okay.
So the next part we're gonna do is that making sure that the vial and the spatula is still suspended liquid, you're gonna hit purge and refill twice. So the first time, and again, it's similar to opening the fill port. You're gonna wait until it goes down and then all the way back up. So what it's gonna do is that it's going to get rid of the liquid it just took up and then take it back up again. So this method, we do it twice to loosen any air bubbles that might be stuck within the syringe. So that's going back up. And purge and refill again.
So after it's doing, it's automatically stop, right?
Yes. So when it finishes the second purge and refill, I usually cap my liquid solution. I could keep it at 4 degrees.
Mm-hmm.
So in case I need to do like a different run or whatever, or I need to use the same concentration in the future, I think the ligand that we work with is generally stable, but I guess it's like on a case-by-case basis because I worked with glycine and that was good for about a month at 4 degrees. But then the protein, I typically want to make fresh each time because we don't know. I mean, with the proteins I was testing, I don't know how stable it was or other properties. So, alright. And remove. Scrap it. And it's good. Okay. And then the more stressful part is actually the loading of the cell solution.